In this video, we're going to take a look at the different imagery sources that are available in Collectors Online, as well as investigate how to import external imagery into the CEO platform. So let's jump right into Collectors Online and take a look at the different imagery sources that are available as a default setting for any of our image interpretation projects. So just like we did in episode 1, we are going to open up our browser window and navigate to Collectors Online. Again, we just click the first link that shows up and then click Open CEO here. And in the last episode, we made our own account and our own institution. So let's go ahead and log into that account and go to our institution homepage. So you will only have one institution, which will appear on the left-hand side of the screen here under Your Affiliations. And then we'll click the Visit button that's just to the right of the text that shows your institution's name. So when we click that Visit button, we're brought to the institution homepage, and here you can see the projects that are in your institution. Of course, right now we don't have any. The imagery that is available for that institution, and the users. So you can add multiple users to the same institution and collect data on the same project. But in this episode, we're going to take a look at the different imagery sources that are available. So as you can see, I haven't done anything with this institution yet, but we already have 4 imagery sources that are available. And these are the Mapbox satellite imagery, both with and without labels. We have the OpenStreetMap base map, and then we have the Planet NICFI public imagery. So this OpenStreetMap data is going to be a lot like your Apple Maps or Google Maps interface. So we're not going to discuss that one in detail in this episode. We're going to take a look at these satellite sources, the Mapbox and the Planet NICFI public imagery. So starting with the Mapbox imagery, so this is a commercial provider, and it sources from other commercial providers as well as open source imagery. And the source that Mapbox pulls from depends on the zoom level that you're looking at, as well as the geographic availability of the data. So for low zoom levels, for zoom levels 0 to 8, it's going to use declouded NASA MODIS data. And that's an open source data set. And then for more intermediate zoom levels, so that zoom levels 8 to 18, we're going to use Maxar Vivid Basic Imagery. And we'll get more into what that means later, but that's a commercial product. And then for very high zoom levels, from zoom levels 14 to 20, we're going to use a combination of different sources based on the location. So over the United States, this will use Nearmap aerial imagery. And then over most of Europe and other cities around the world, we're going to use open source aerial imagery. So most of the time when we're looking at Mapbox satellite imagery in Collectors Online, we're going to be looking at it at a very high zoom level. So we're most of the time going to be viewing that Maxar Vivid Basic product. And so Maxar is a commercial provider, and the advantage of this data here is that it's very high spatial resolution. So it's up to 30 centimeters spatial resolution, so it's really great for seeing individual land cover objects such as trees or bushes on the ground. Where this data is lacking is that it's not time-stamped. So because it's pulling the most clear and the most current imagery, it's not time-stamped in any way. And so oftentimes this imagery alone is going to be insufficient in satisfying the objectives of your image interpretation project. And so that brings us to the Planet NICFI public data. So this data set, while it doesn't nearly have the level of spatial resolution of the Mapbox data, spatial resolution is a little less than 5 meters, it makes up for that in the fact that it is time-stamped and it has monthly composites for more recent imagery. So this imagery starts in December of 2015, and from there to June of 2020, there's bi-yearly composites. From June 2020 to August of 2020, there's a 3-month composite. And then from there until present day, with a latency of about 2 months, we have monthly composites. So this is a low spatial resolution but high temporal resolution imagery, and the Mapbox satellite has very high spatial resolution, but it does not tell you any information about when that image was acquired. So we'll see later in our data collection episode that we're going to use a variety of these different sources in order to come to a conclusion about what land cover type we're seeing. And sometimes, depending on the objectives of your image interpretation project, these two sources alone may not be sufficient in achieving the objectives of your project. And so that's why Collect Earth Online allows you to import external imagery into the software. And we do that through this Add New Imagery button right here. So if we click the text under the text that says Select Type here, we can see all the different methods that we can use to import imagery into Collect Earth Online. So we have this web map service imagery. So if your institution has imagery already uploaded online on a web map service server, you can just type in the URL here to bring it into CEO. We also have commercial providers. So if your organization has purchased imagery from one of these providers, you can just type in the access key here, and then your imagery will be available in CEO. But since Severe is all about open science, we're going to focus on the open source imagery in this video. So that's going to be the Sentinel program, which is launched by the European Space Agency's Copernicus mission, as well as the Google Earth Engine imagery. So let's start with Sentinel-1. So this is going to be an active sensor, so it's transmitting as well as receiving electromagnetic radiation, unlike a passive sensor, which you may be more familiar with, that is just receiving the radiation that was reflected by the Earth and originally emitted by the Sun. So this imagery has a spatial resolution of about 10 meters, and it has a temporal resolution of about a month. And the temporal extent of the Sentinel imagery is from 2014 until present day. So to import this imagery into our institution, we're just going to type in a title. So we'll just call it Sentinel-1, and then the default year, and this will be the year that Collect Earth Online displays as a default when we're viewing the image in our project. We'll be able to view the entire collection of Sentinel-1 imagery. So this doesn't matter too much what you type in here. Just note that it has to be in between 2014 and 2023. So we will just say 2020, and then we enter in a default month. So I will just type in June. You type it in as an integer, not as the actual name of the month. So I'll type in 6 there for June. And now we want to select the band combination that we want to represent our Sentinel-1 data as. So if you're unfamiliar with band combinations, the first code here is going to be what we assign to the red channel. The second code is what will be assigned to the green channel, and the last code there will be assigned to the blue channel. And if you've never worked with synthetic aperture radar data before, you may be confused as to what these polarization codes are, but that is exactly what they are. It's a way to represent the polarization of the signal that Sentinel-1 uses. So because Sentinel-1 is an active sensor, we can control the polarization of the electromagnetic radiation, both when it's transmitted as well as when it's received. So this first letter in the code here is going to be the polarization of the signal upon transmission, and the second letter in the code is going to be the polarization when it is received. And V here stands for vertical polarization, whereas H stands for horizontal polarization. But the important thing to note here is that different polarization modes will reflect some land cover types better than others and allow you to more easily identify them. So again, this is all going to depend on the objectives of your image interpretation project. So we will just select the first band combination, and then we are going to specify a minimum and maximum value. So this minimum value for Sentinel-1 data can be as low as -50, but a good minimum value is 0. And then for the maximum value, this can be as high as 1, but usually a good value for this is 0.3. And then finally, we can check this box if we want this imagery to be added as a default to all image interpretation projects that we make in this institution. So I'll just go ahead and click that. And then all we need to do is click Add New Imagery. And we can see that we have the Sentinel-1 imagery available in our institution. And if we choose, we can go back and edit it at any time. So now let's add Sentinel-2 imagery to this institution. So again, we're going to click the Add New Imagery button and scroll down in the drop-down menu here where it says Sentinel-2. Then, just like Sentinel-1, we'll assign a title to this imagery as well as a default year and a default month. Then we're going to want to pick the band combination to represent our Sentinel-2 data. So as you can see, the default option here is a true color composite. So that's an image that's similar to how you see with your own eyes, where red light is assigned to the red channel, green light is assigned to the green channel, and blue light is assigned to the blue channel. But we also have what's called these false color composites here, where we're assigning different colors or different bands of maybe non-optical radiation to those red, green, and blue channels respectively. So each of these options here refers to a different combination of optical and near-infrared or shortwave infrared light. And you can see what each of these options corresponds to what wavelengths of radiation in the Collect Earth Online documentation. So in this case, I just want a true color image, so I'm going to pick true color. So finally, we want to specify a good minimum and maximum value for the visualization of Sentinel-2 here. And just like Sentinel-1, a good minimum value is 0, and a good maximum value is generally somewhere around 0.3. And then the final parameter we want to give here to Collect Earth Online is going to be the cloud score. So this is going to be the maximum percentage of cloud cover that we allow a Sentinel-2 tile to have for it to be imported into Collect Earth Online. So if we enter in 30 here, any Sentinel-2 tile that has a cloud cover percentage of 30 or more will not be imported into Collect Earth Online. So I will finally click this checkbox that says Add Imagery to all projects when saving, and click Add New Imagery. And as you can see, it's as simple as that. We now have Sentinel-1 and 2 imagery available within this institution. We can also import imagery from Google Earth Engine into Collect Earth Online, and we do that by selecting GEE Image Collection Asset or GEE Image Asset from the drop-down menu here. So first I'm going to show you how to import an image collection asset into Collect Earth Online. And you can see that to be able to import this type of imagery, we're going to need both an asset ID as well as what's called visualization parameters. And if you have worked with Google Earth Engine before, you're likely familiar with what these mean. But if you have not worked with GEE before, I'm going to show you how we can find out the asset ID and the visualization parameters. So Google Earth Engine is free to use, but you do have to register and make an account before you can use it, and that can take up to a couple days. But once you are registered, you can navigate to code.earthengine.google.com, and that will bring you to the GEE code editor. So we can search Earth observation data sets up in this search bar at the top here. And so I'm going to show you how to import a data set called the NAIP data, which is the National Agricultural Imagery Program, and this is a data set that's available over the United States. So if my image interpretation project was over the US, I might want to import this data into Collect Earth Online for use in my project. So by clicking on the data set here, we can see a description about the data set as well as what bands are in the imagery. So the asset ID parameter is going to be located here under where it says collection snippet, and it's going to be what is located in between these quotation marks, including the quotes themselves. So we are going to copy that here, go back to Collect Earth Online, and paste that in. And we can also add a title. We'll just call it NAIP. And now we want to find out some good visualization parameters. So to do that, we can just find out very quickly in Google Earth Engine what some good visualization parameters might be. So first I'm going to import this data set into the GEE code editor, and I can give it a name, call it NAIP. And then we're just going to visualize a random scene of this data. So I'm just going to take a geometry over an arbitrary location, and then we can filter this data set to that location using the filter bounds method in GEE. I'll also filter to a specific time period. Again, this is just arbitrary. We just want to get an image for visualization. and then I will make a median composite of all of those images to reduce them into a single image. And so we can add that layer to the map here. And we'll call this image NAIP filtered, and we will go ahead and add that to the map by using the add layer method. Oh, and I meant to say filter date here instead of just filter. So again, we're filtering to this region and filtering to a specific time period of interest. And you can see our image shows up there in Google Earth Engine. So in order to bring this into Collect Earth Online, we're going to need to specifically specify some things to Collect Earth Online. And so those are the bands that we want to use from the image, a minimum value for the image, and a maximum value for the image. So Google Earth Engine knows it has some default parameters to use for these visualization parameters, but we're going to have to explicitly define those to bring this image into Collect Earth Online. So we can find out what bands are available in this imagery by using the band names function, or method rather, in GEE. So I'll say bands equals NAIP filtered, which is my image here, dot band names, and then we can print that to the GEE console to see what bands we have available. So here you can see we have R, G, B, and N. So these are the available bands in the NAIP imagery, and we can also view what those mean by going back to this image in the search bar and clicking where it says bands here. So here we can see that R corresponds to visible red light, G corresponds to green light, B to blue light, and N to near infrared light. And we can also see that the units are a DN, which stands for a digital number. But if you didn't know what that meant, you could simply go to the Layers tab in Google Earth Engine and click this gear here. And you can see that the parameters or the min and max value for this data set, it has a minimum value of 0 and a maximum value of 255. And so we can also specify these visualization parameters in Google Earth Engine. So I'll just create a variable called VP. And then what I want to do is, in quotes, give it bands. And we are just going to use a true color image. So we're going to use red, also enclosed in quotation marks, comma, green, comma, blue. And so that will be a true color image like we see in the map here. And then we'll specify a minimum value of 0 and a maximum value of 255. But different data sets might have different minimum and maximum values, and so that's why I recommend just adding a filtered image to the map here and then clicking on this gear icon to play around with the visualization parameters. So we can click on different stretching parameters here, and that might provide us with a better and more rich picture. So if we wanted to use these different visualization parameters with a minimum of about 59 and a maximum of 190, we can do that as well. So now we have our visualization parameters. We can test these out in Google Earth Engine before we try to bring it into Collect Earth Online by just adding a second argument to the .add layer method here. And then we'll run it again to make sure that works. It looks like it's doing just fine. So we can grab this JSON object here, which just means that it's enclosed in these braces and each argument is identified with quotation marks. So we'll just copy that, and then we'll go back to Collect Earth Online and paste that in here where it says visualization parameters JSON format. And you can see here it provides a guide of how you can do that. So we'll paste that in, and then finally we just need to provide a start date and an end date for when we're viewing this in Collect Earth Online. So if my image interpretation project was just looking at the year of 2020, I would set the start date obviously to the first of the year and through to the end of that year. And you just want to make sure, of course, that the data set that you're trying to bring in actually has acquisitions for that time period. So all I want to do at the end is click Add Imagery to all projects when saving, and we can just click Add New Imagery. And now we can see I have my NAIP imagery available for this institution. So that's an example of how we can bring in what's called an off-the-shelf asset. It's just there in Google Earth Engine, and it's ready to be added into Collect Earth Online. But Google Earth Engine also allows you to have personal assets, and these can be images or image collections as well. And so we're going to see now that you can also import these personal assets into GEE. And if I wanted to do the same for a image asset rather than an image collection asset, you're going to see that it's largely the same. We just need that asset ID and then visualization parameters. So how will we go about adding a personal image collection asset into Collect Earth Online? So if you have your own image collection asset, it will show up here in the Google Earth Engine code editor under the Assets tab. So as an example, I'm going to show you how to import a digital elevation model over West Africa, specifically the country of Senegal. So this is a DEM that Servier has created and uploaded to Earth Engine. And to be able to bring this into Collect Earth Online, we're going to need to make this asset public. So we can do that by clicking the Share button at the top there, and then you want to make sure that this box that says anyone can read is checked off, because as a default it will be unchecked. And if this is the case, you won't be able to bring this asset into Collect Earth Online. So we want to make sure that box is checked, and then we will go through the same process where we find some good visualization parameters. Again, we just collect the asset ID by copying and pasting right here, just as we did with the off-the-shelf asset. So that concludes this episode. We know how to import imagery from Sentinel-1, Sentinel-2, as well as any image collection asset that's available in Google Earth Engine, or any image asset that we've uploaded to GEE. So that is it for this episode. In the next episode, we're going to take a look at how you plan out an image interpretation project, and then we're going to get started creating our own project in Collect Earth Online. So thanks for listening. Collect Earth Online has received financial support from NASA, the U.S. Agency for International Development, or USAID, the Food and Agriculture Organization of the United Nations, or FAO, the U.S. Forest Service, Silva Carbon, Google, and the Spatial Informatics Group. It was co-developed as an online tool housed within the Open Forest Initiative of FAO. Collect Earth Online was initially developed by Servier and is now supported by a broad base of partners. And it was inspired by Collect Earth, a desktop software developed by FAO. The development team of CEO includes Arthur Lewes, Jordan Combs, Matt Spencer, Richard Shepard, Oliver Baldwin Edwards, Sif Beery, Roberto Fontanarosa, Francisco Delgado, Githika Tondapu, Billy Ashmall, Nishanta Kanal, John Dilger, Karen Dyson, Karis Tennyson, Cal Markert, Africa Flores, Emil Sherrington, and Eric Anderson. The Collect Earth Online curriculum was organized by Servier's Science Coordination Office, with individual models created by NASA, USAID, NASA's Earth Observatory, the Spatial Informatics Group, and Servier's Science Coordination Office. These individual modules were created by Crystal Wespestad of Spatial Informatics Group, Holly Rybeek and Robert Simon of NASA Earth Observatory, Billy Ashmall, and myself, Mickey Maganini, of Servier's Science Coordination Office. Review of the material was conducted by Servier's Science Coordination Office, including Kelsey Herndon, Emil Sherrington, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthen, Natalia Bermudez, Stephanie Melick, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Francisca Delgado, Biplab Bhandari, and Amanda Markert. Crucial insight regarding the development of the curriculum materials was provided by Claudia Paris and Andrea Puzzi-Nicolau. Review of the material was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geo-information Science and Earth Observation at the University of Twente. The course and unit banner images used in the course were created by Gianluca Ambrosi of ITC.